Myself is Tejasri Kosbe, lecturer from Praveen Patil Polytechnic Bhayandar. My topic is Measuring Instrument Part 4, Learning Outcomes. In this video, you will learn about purpose of earthing, factors affecting on earth resistivity and earth tester. So first is purpose of earthing. First is safety for human life or building or equipment. To save human life from danger of electrical shock or death by blowing a fuse, that is to provide an alternative path for the fault current to flow so that it will not endanger the user. To protect buildings, machinery and appliances under fault conditions, to ensure that all exposed conductive parts do not reach a dangerous potential, to provide safe path to dissipate lightning and short circuit currents, to provide stable platform for operation of sensitive electronic equipment, that is to maintain the voltage at any part of an electrical system at a known value so as to prevent overcurrent or excessive voltage on the appliances or equipment. Second is overvoltage protection. Lightning surges or unintentional contact with higher voltage lines can cause dangerously high voltages to the electrical distribution system. Earthing provides an alternative path around the electrical system to minimize damages in the system. Third is voltage stabilization. There are many sources of electricity. Every transformer can be considered a separate source. If there were not a common reference point for all these voltage sources, it would be extremely difficult to calculate their relationships to each other. Next one is factors affecting on earth resistivity. So first factor is soil resistivity. It is the resistance of soil to the passage of electric current. The earth resistance value of an earth pit depends on soil resistivity. It is the resistance of the soil to the passage of electric current. It varies from soil to soil. It depends on the physical composition of the soil, moisture, dissolved salts, grain size and distribution, seasonal variation, current magnitude, etc. It depends on the composition of soil, moisture content, dissolved salts, grain size and its distribution, seasonal variation and current magnitude. Second is soil condition. Different soil conditions gives different soil resistivity. Most of the soils are very poor conductors of electricity. When they are completely dry, soil resistivity is measured in ohm meters or ohm centimeter. Soil plays a significant role in determining the performance of electrode. Soil with low resistivity is highly corrosive. If soil is dry, then soil resistivity value will be very high. If soil resistivity is high, earth resistance of electrode will also be high. Third one is moisture. Moisture has a great influence on resistivity value of soil. The resistivity of the soil can be determined by the quantity of water held by the soil and resistivity of the water itself. Conduction of electricity in soil is through water. The resistance drops quickly to a more or less steady minimum value of about 15% moisture, and further increase of moisture level in soil will have little effect on soil resistivity. In many locations, water table goes down in dry weather conditions. Therefore, it is essential to pour water in and around the earth pit to maintain moisture in dry weather conditions. Moisture significantly influences soil resistivity. Fourth, dissolved salts. Pure water is a poor conductor of electricity. Resistivity of soil depends on resistivity of water, which in turn depends on the amount and nature of salts dissolved in it. Small quantity of salts in water reduces soil resistivity by 80%. Common salt is most effective in improving conductivity of soil, but it corrodes metal and hence discourage. Fifth one is climate condition. Increase or decrease of moisture content determines the increase or decrease of soil resistivity. Thus in dry weather, resistivity will be very high, and in monsoon months the resistivity will be low. Sixth one is physical composition. Different soil composition gives different average resistivity. Based on the type of soil, the resistivity of clay soil may be in the range of 4 to 150 ohm meter, whereas for rocky or gravel soils, the same may be well above 1000 ohm meter. 7. Location of earth pit. The location also contributes to resistivity to a great extent. In a sloping landscape or in a land with made up of soil or areas which are hilly, rocky or sandy, water runs off and in dry weather conditions, water tables goes down very fast. In such situation, backfill compound will not be able to attract moisture as the soil around the pit would be dry. The earth pits located in such areas must be watered at frequent intervals, particularly during dry weather conditions. Next is the earth tester. The instrument used for measuring the resistance of the earth is known as earth tester. All the equipment of the power system is connected to earth through earth electrode. The earth protects the equipment and personnel from the fault current. The resistance of the earth is very low. The fault current through the earth electrode passes to the earth, thus protects the system from damage. The earth electrodes control the high potential of the equipment, which is caused by the high lightning surges and the voltage spikes. The neutral of the three-phase circuit is also connected to the earth electrodes for their protection. Before providing the earthing to the equipment, it is essential to determine the resistance of that particular area from where the earthen pit can be dug. The earth should have low resistance so that the fault current easily passes to the earth. The resistance of the earth is determined by the help of earth tester instrument. So this is the construction diagram for earth tester. In this diagram you can see there is a DC generator, current reverser, rectifier, potential coil, current coil, and there are 4 terminals for connection. C1 and P1 are shorted and are connected to E1. P2 and C2 are connected with P and C respectively. The earth tester uses the hand-driven generator. The rotational current reversal and the rectifier are the 2 main parts of the earth tester. The current reversal and the rectifier are mounted on the shaft of the DC generator. The earth tester works only on the DC because of the rectifier. The tester has 2 commutators placed along with the current reverser and rectifier. Each commutator consists 4 fixed brushes. The commutator is a device used for converting the direction of flows of current. It is connected in series with the armature of the generator, and the brushes are used for transferring the power from the stationary parts to the moving parts of the devices. The arrangement of the brushes can be done in such a way that they are alternately connected with one of the segments even after the rotation of the commutator. The brushes and the commutators are always connected to each other. The earth tester consists 2 pressures and the current coils. Each coil has 2 terminals. The pair of the pressure coil and the current coil are placed across the permanent magnet. The one pair of current and pressure coil is short circuited and it is connected to the auxiliary electrodes. The one end terminal of the pressure coil is connected to the rectifier and their other end is connected to the earth electrode. Similarly, the current coil is connected to the rectifier and earth electrode. The earth tester consists the potential coil which is directly connected to the DC generator. The potential coil is placed between the permanent magnet. The coil is connected to the pointer and the pointer is fixed on the calibrated scale. The pointer indicates the magnitude of the earth resistance. The deflection of the pointer depends on the ratio of the voltage of pressure coil to the current of the current coil. The short circuit current passes through the equipment to the earth is alternating in nature. Thus, we can see that the alternating current flows in the soil. This alternative current reduces the unwanted effect of the soil, which occurs because of the chemical action or because of the production of back EMF. Next method is Follow potential method. The measurement of earth resistance is made by the potential fall method. The resistance area of the earth electrode is the area of the soil around which a voltage gradient is measured with a commercial instrument. In the figure shown below, E is the earth electrode under test. A is an auxiliary earth electrode positioned so that two resistance areas do not overlap. B is the second auxiliary electrode which is placed between E and A. So this is the diagram for follow-up potential method. Here you can see there are three electrodes E, B and A. Voltmeter is connected to measure the voltage and ammeter is connected in series to measure the current. An alternating current of steady state value passes through the earth path from E and A and the voltage drop between E and B is measured. RE is equal to voltage drop between E and B upon current through earth path. So RE is equal to V upon I. The electrode B is moved from position B1 and B2 respectively so that the resistance area do not overlap. If the resistance values determined are of approximately the same in all three cases, the mean of the three readings can be taken as the earth resistance of the earth electrode. The auxiliary earth electrode A must be driven in at a point further away from E and the above test repeated until the group of the three readings obtained are in a good agreement. The alternating current source is used to eliminate the electrolytic effect. The test can be performed with current at power frequency from a double wound transformer using a voltmeter and an ammeter as shown in figure above by means of an earth tester. The earth tester is a special type of measure which sends AC through earth and DC through the measuring instrument. It has got four terminals. Two terminals are shorted to form a common point which is connected to earth electrode under test. The other two terminals are connected to the auxiliary electrode A and B respectively. The value of the earth resistance is indicated by the instrument directly when its handle is turned at a uniform speed.